Hello, everyone, and welcome to Climate Conversations. I'm your host, Kathy Yang, and today we'll be talking about the Urban Heat Island Effect, or UHI. So, first of all, what is the Urban Heat Island Effect? It's a phenomenon where a city or an urban area has higher temperatures than its surroundings. There are two types of heat islands: surface heat islands and atmospheric heat islands. Surface, as the name suggests, refers to different temperatures found within different surfaces and materials, and atmospheric heat islands refer to the air masses that are warmer above urban areas compared to surrounding rural areas. So according to the Environmental Protection Agency, temperatures in the daytime are 1 to 7 degrees Fahrenheit higher and 2 to 5 degrees Fahrenheit higher in the nighttime over an urban area. Cities like New York, San Francisco, Miami, Baltimore, Atlanta, etc. are all affected and are currently facing urban heat islands. For some specific details, according to Climate Central and Columbia, New York City's environment is making temperatures 9.7 degrees Fahrenheit hotter than the average resident would experience otherwise. So now let's talk about the causes and what leads to an urban heat island. So the main thing that causes urban heat islands are the infrastructure, roads, and buildings found within a city. So all the infrastructure in a city has relatively low albedo, meaning that less solar radiation is reflected and more energy is absorbed. Materials like concrete and asphalt have high heat capacities and are able to absorb a lot of heat. These materials are impervious, meaning that water cannot travel through them, and we'll talk more about this later and how this can lead to higher temperatures. Another major factor is the reduced amount of trees and greenery. So reduced natural landscape and trees just in general reduces the amount of shade on the ground and exposes a lot more surface to the sun. Now let's talk about why plants and having permeable, breathable materials are so important. Plants can transpire, meaning that they can lower temperatures surrounding them. It's similar to the way humans sweat to cool down and dispel energy. And without these plants doing natural evaporation and transpiration, temperatures can get very, very hot quickly. Another factor that plays into the creation of urban heat islands is the amount of pollution and transportation like cars that emit carbon dioxide and fossil fuels. The physical involvement of buildings obstructing wind patterns and wind flow can also just trap heat and energy in one specific area. So these all come together to help create urban heat islands. And now let's talk about how scientists can measure urban heat island effects. So remote sensing satellites, specifically like NASA's Landsat, can use their thermal bands to directly measure a city's temperatures to help create maps where it's easy to visualize where like hot spots of the urban heat island effect are occurring. Next, we can focus on the effects of the urban heat islands. So obviously the UHI increases temperatures in a city, therefore increasing the need of air conditioning and electricity. So this also increases the amount of emissions that humans put out into the atmosphere, further fueling climate change. Moreover, human health is negatively impacted. Humans are more susceptible to heat strokes and heat-related illnesses when living in polluted and warmer cities. Additionally, this impact of the UHI is disproportionate among different communities. meaning that low-income groups are more heavily impacted. Lastly, temperature changes can damage ecosystems overall. Now let's talk about the solutions and what can be done to help better the conditions that UHI is currently imposing. The number one priority would be to increase the amount of vegetation. This would increase the albedo, but also help get more transpiration and evaporation going, which can help cool the air. Another solution that the EPA proposes are green roofs. So these are roofs that are partially or fully covered with vegetation. And according to the EPA, the surface temperature of green roofs can be almost 60 degrees Fahrenheit lower than those of conventional regular roofs. And they can also help to reduce nearby air temperatures by up to 20 degrees Fahrenheit. There are two types of green roofs, extensive and intensive green roofs. And then lastly, creating more open, varying levels of infrastructure in cities can help to mitigate the UHI. So having buildings of even different heights can help to improve airflow. Thank you so much for watching this episode, and I hope to see you all next time. Bye!